This is our recitation, second recitation. Problem 4. For problem 4, we will have charge Q that is uniformly spread from YA to Y minus B. Charge Q that is uniformly distributed along this line. Q is uniformly spread from Y minus B to Y equals to A. We want to find the electric field created by this charge Q at point x equals to L. Find the electric field. Find the electric field. At point x, L, y, 0. We will use Coulomb's law to find out what is electric field, because we know what is electric field created by point charge. So if I have point charge Q, then electric field created by this point charge is just coefficient Q charge divided by distance squared, and this electric field is in radial direction. Either I put unit vector IR, depends on the IR that is radially out, or I just put unit vector R hat, depends on notations. I will use the same notations as the book uses, so I will use IR with the vector. This is electric field created by point charge, but we have charge that is extended along this rod. So we need, as usual, we need to make our point charge. I will choose some arbitrary point Y, and I will choose infinitesimally small interval that has length dy, and charge that is within this infinitesimally small interval will be dq. So what is electric field created by this infinitesimally small charge dq? The electric field, we have to write dE, it's infinitesimally small, is k. It is dq divided by r squared, and we need unit vector. So what I will do next, let's draw this electric field created by dq at this point. Electric field will be along this line. This is dE. And all I need to do now, I need to find x and y components of this electric field, and then I will integrate it from minus b to a along this rod. So what is dE x component of electric field? DEX. DEX is k dq, infinitesimally small charge, divided by distance squared. Distance between dq and this point L we will find using this right triangle. This hypotenuse is this leg squared, L squared, plus this leg squared, this is y squared. I remind you that dq is at arbitrary point y, so it is L squared plus y squared, and this is distance squared, r squared. And to have x component, I need to introduce angle. Let's introduce angle with horizontal, for example, theta. To have x component, I need to multiply by cosine theta. Cosine theta. This vector is vector sum of these vectors and this vector, so x component is positive. We put plus here, and this is x component, we don't forget to put unit vector ix. Y component of electric field, d e y, is negative. So I have minus k dq divided by L squared plus y squared, and we multiply by sine theta. Now we need to express dq, cosine theta and sine theta in terms of what is given, and then we integrate both components of electric field. So what is dq? Let's start with dq. dq, infinitesimally small charge within dy, by definition, is lambda, charge per unit length, dy. Lambda is charges uniformly spread over this rod. So lambda is just charge divided by length. Charge is q, length is a plus b. Q over a plus b. This is lambda, and then I'll bring it here. So it is q divided by a plus b dy. This is dq. Now I need to find out cosine theta and sine theta. Cosine theta we will find from this right triangle. Cosine theta, this is theta, so cosine theta is adjacent leg L divided by hypotenuse, which is L squared plus, this is y, L squared plus y squared square root. Sine theta is opposite leg to theta, which is y, divided by square root L squared plus y squared square root. Now we are ready to bring everything back into our formulas and integrate from minus b to a. So my Ex, x component of electric field, will be integral from minus b to a, from minus b to a, dq, no, k, then dq, I will write dq in red. dq is q over a plus b dy, and I also have here L squared plus y squared. Let's leave dy here. This is dq, and then I have 1 over L squared plus y squared, this guy, and then cosine theta, which is L, divided by square root of L squared plus y squared. I have L squared plus y squared to 3/2. And that's it. So we have dq here, we have cosine, and we have all other guys. So if we take this integral, we will have our final answer for Ex. I will leave it as an integral. And now what I will do, I will write Ey as an integral. Ey is minus integral from minus b to a, k. dq is q over a plus b dy. I will put dy here. And then the rest of Ey, we have L squared plus y squared. And we have sine theta, which is y, divided by square root of L squared plus y squared, which will bring me to L squared plus y squared to 3/2. And I will leave this integrals, we will not take them. So we found x and y components of electric field, and we understand that if we know both x and y components, we know the resultant electric field. It will be Ex Ix plus Ey Iy. Now I change my mind. instead of Q being uniformly spread over this interval, we will have Q that is non-uniformly distributed along this rod. So, how we will solve the problem when Q is not uniform? Which means that lambda is not Q over A over B. What is lambda in this case? It has to be given. So I give you lambda. It's given that this charge Q is distributed such that lambda as a function of y is lambda naught 1 plus y over A. Where will be the difference in our solution? Will dEx, this expression, be the same or different? Here we still have dq. The difference will be in dq. So we need to write new dq. dq is by definition lambda dy. Lambda is not q over a plus b, it is given. So I have dq that is equal now to lambda naught 1 plus y over a. This is lambda, and then dy. This is my new dq. So I need to plug in dq in my final formulas. I raise this q over a plus b. I raise everything in red because q is different now. dq is different now. What will be dq? It will be lambda naught, then 1 plus y over a, 1 plus y over a, dy. The integral we still take with respect to y. This is our variable of integration. And I do the same for ey. Here was dq, so dq is lambda naught 1 plus y over a dy. Again, we know both components of electric field. We solve the problem. Now with lambda that changes with y. Q was not uniformly distributed. We can solve both problems.